Okay, we're going to take a test on Wednesday. It's going to be your first assessment on this. This is not a very long standard, okay? Polynomial expressions, simplify that these are polynomials, okay? That's a polynomial, that's a polynomial. It's just got a bunch of numbers with variables, and the variables are different exponents, and there are pluses and minuses, so don't be making the three lines, okay? Now, the question is, do I need to make rainbows? Do I need to distribute? No, because there's a plus sign in between. So we just collect like terms. Now, the highest power we have is x to the second. So I line up my blanks. So we have 8 and negative 11. I combine those. It's going to be negative 3. Now, x, not x to the second, has to be x. X to the second and x are two totally different terms. We have a negative 3 and a positive 2, so I add those, it's negative 1. Now the constants, we have a negative 10 and negative 7, that's going to be negative 17. Okay, now if there is a subtraction sign, then there is no distribution, okay, no rainbows. So x third, x second, that'd be 1x in that polynomial, minus, and if we have a minus, we're actually going to make it a plus, and that's going to be negative 15, that's now going to be negative 7, that's now going to be positive 8. We don't switch the first, just anything after that, in the polynomial after it. And then it's the same thing here. But you have to look a little closer, okay? X third, x second, x second, x constant. So x third's the highest. Okay, so x to the third, we have a 6. And we don't have, I'm writing 6 down because that's all I have. I don't have anything in that polynomial as far as x to the third. X to the second. Well, we have a 12 in that polynomial and a negative 15 in that. So those go together. X second, 12, negative 15 is negative 3. Now x. X means x to the first power. They normally don't put first powers, but they are implied ones if the x doesn't have a power. We have a negative 1 here, a negative 7 here. So negative 1 plus negative 7 is negative 8. Then for constants, I don't have any constants here, but here I have an 8. Okay, now those are easy. Now the next one, we do have multiplication, because this right here is called a monomial because there's only one term. This is a polynomial. So now I start my rainbow, my distribution. So I made 4 rainbows, all from the 5x to the 4th. Okay, so 5x to the 4th times 2x to the 3rd times negative 3x to the 2nd times 5x times negative 1. So 5 times 2 is 10. Then x to the 4th times x to the 3rd. You don't multiply the exponents, you add them. X to the 7th. 5 times negative 3 is negative 15. You don't multiply the exponents, you add them. 5 times 5 is 25. You don't multiply the exponents, you add them. 4 plus 1 is 5. 5 times negative 1 is negative 5, and I just write that x to the 4th power after the negative 5. Now all those powers are different, so you can't combine them, but you need to write the sentence out as 10x to the 7th. And don't write times anymore. The times is done. I saw some of you on this assignment doing that, and I'm not mad about it, okay? But don't write dots now. You write minus 15x to the 6th. It's plus and minus now. Plus 25x to the 5th. Minus 5x to the power of 4. Timesing's done. I did that, okay? No more multiplication. Okay, next problem, next page. Now, in between the two binomials is a times sign, so you have to start doing distribution, okay? So, first go with your 3. So distribute, distribute. That was 2 rainbows, so 3x, 3x, times 1x and times 5. Now I also have to distribute the -7 times 1x times 5. So 3 times 1 is 3. X times x is x to the second. 3 times 5 is 15 with an x factor. -7 times 1 is -7 with an x factor. And -7 times 5 is -35, and that's a constant. So I can see that I have some like terms. That's the only x to the second. That's the only constant, but both of these have x's. So line up your spaces. Starting with x to the second, the degree is 2, x to the second. So we have 3. 15 plus -7 is 8, and then -35. Okay, next one, all these are going to be multiplication problems, so you might as well start your rainbows. Okay, so 3, oh, sorry, I'll distribute first so I know how many 3x's I'm distributing. Okay, so 3x, 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 times 2x to the second, times -5x, times 6. That's done. Now repeat your procedure with your -2. Okay, now we find the 6 products. So 3 times 2 is 6. Now x times x to the second, I am going to put a 1 here and add the powers. That would be x to the power of 3. 3 times -5 is -15. Then x times x is x to the second. 3 times 6 is 18x. -2 times 2 is -4, and I just put x second. -2 times -5 is 10. I just put x. -2 times 6 is -12. That's a constant, meaning there's no variable. Okay. So we got 6x third, -15x the second, 18x, -4x the second, 10x, -12. Now obviously things go together. We have 2 different x to the seconds. We have 2 different x's. So x third's the highest though. So I start my polynomial with x to the third. So x third we have 6. X second we have -15, -4. Okay. Adding those gives me -19. Then the x's we have 18 plus 10. That would give me 28 of those terms. And then -12. Done. Okay. Okay, so on our next problem, we have the parentheses 4x minus 5 to the second. Now circle that minus. That means it is a binomial, B-I-N. You cannot use the 3 lines like you can on these, because here there's no pluses and minuses, no pluses and minuses, no pluses and minuses. Here I have a minus. So instead of the 3 lines, we get rid of the power and we just make a copy of the parentheses. And then we need to do the distribution. Okay, so 4 to 4, 4 to -5. Done. -5 to 4, -5 to -5. So 4 times 4 is 16, x to the second. It's going to be -20x. Another -20x, and then 25. Okay, so x second we have 16. X, -20, -20 adds up to -40, and then you have 25 as your constant. Okay. Okay, next one, another multiplication, so we have to do some distribution. So 4, 4, 4, 2. So 4x is being distributed to two things. One is a 4x, the other is a 2. Then the negative 2 has to be distributed. So 4 times 4 is 16, x to the second. 4 times 2 is 8x. Negative 8x, negative 4. Okay, those are like terms, so the degree is 2. So we have 16. 8 and negative, ooh, that adds to 0, so let's just get rid of that. Okay, and then negative 4. 16x to the second plus negative 4. Okay, now there is a story problem. A garden has dimensions of 15 by 17 feet. You're going to build a rectangular border that is the same width on every side. Okay, so draw the rectangle. You have 15 by 17. I know that's messed up because 17 is longer than 15. It don't matter. Okay, put it inside though. Now we're building a border on the outside. So write a polynomial expression that represents the area of the garden and border. So remember, area is two factors, the length multiplied by the width. So here's my length of the whole thing, not just the middle. So you know the inside part's 15, but the outsides we don't have, so they're x's. So I put 1x, 1x. So that's going to be 2x plus 15. Then the width. So from here to here is 17, and that's going to be 2x plus 17. Okay, you need to multiply that out now. Okay, you don't draw the blanks because you have to do the rainbows. This distributed property. So 2 to 2, 2 to 17 times 2x times 17. Now that's been distributed. Now we do the 15. So 2 times 2 is 4, x times x is to the second power. 2 times 17 is 34x, 15 times 2 is 30x, 15 times 17, 255. So x second, we're going to have 4x, 34 plus 30 is going to be 64. And then 255. Okay, use your expression to calculate the combined area of the garden and border if the border has a width of 8 feet. That means x is 8. So we're going to have to find our area. We're just going to replace that x and that x with 8. Okay, so 4, if you want to write dot 8, fine, I'm going to write parentheses 8. We need a second power on that first 8. Plus 64. And then dot 8 or parentheses 8 plus 255. Okay. Okay, then just go to your calculator. 4 parentheses 8 to the second. You can go caret 2 or you can just hit the key next to the 7. Okay, I got 1023, and the label on that is feet squared, because it's area. Okay, so that's it on that. Now, you are going to take your second assessment on this, and that's going to be the last one. We're only taking assessments twice. We're not going to have enough time to get it in 3 times, because it takes longer. So you took this last week, take it again, and it's done. Okay. Now this time you are going to make your 3 lines because there's no pluses and minuses within the expression. So we got a base 2, a base m, a base n. So 1 times 3 is 3. Now we have 2 factors of m, so we're going to add the powers. So 3 times 3 is 9, and then plus 7. 9 plus 7 is 16. Then n, there's only this factor, but we have to raise the 2. We have to take 2 times 3. That's 6. None of these are negatives, so they all stay exactly where they're at. Okay, 2 to the third can be simplified. 2 times 2 times 2 equals 8. So that becomes 8 times n to the 16 times n to the 6th. Okay, number 2. Your factors are 5 and x. Underline it if you want, because everything starts on the top. So it's 5 to the first, but we got to take 1 times negative 2. That's negative 2. Negative 2. Now, you do have negative powers, so those need to go to the bottom so they can now become positive powers. And you need something to cover the top. You can't have an open top. 1. So I can figure out 5 to the second. It's 5 times 5. That's 25. Okay, next one, number 3. This is kind of a weird one. You follow the rules in the algorithm, you'll get it. You have base 6 on top. Okay, it's to the first. It's the parentheses is there, but it's not around the 6. Now at bottom I've got 2 bases. I have a 2 and a y. So 2, 1 times negative 3 is negative 3. 1 times negative 3 is negative 3. Okay, you got some negative exponents. You need to rewrite them as positives. Now they are on the bottom, okay? These two right here have negative exponents. If they are on the bottom, you raise them up to the top, and then they can then be positive. Just come up. So 6 to the first then is 6. 2 to the third is 2 times 2 times 2. That's 8. And then y to the third. So I take 6 times 8. That's 48. 48 times y to the third. Okay, number 4. Same. You're trying to do the same thing. Okay, remember 2 fractions multiplied means we can just make one fraction with a top and a bottom. So on top you got a base 5, a base 4, and a base a. So 5 times 1, 1 times 3 is 3. There's one base of 4, 1 times 3 is 3. There's this base of a, 2 times 3 is 6. Now in the denominator you have a factor of a and a factor of b. So a, 1 times 3 is 3. B, 1 times 3 is 3. Now, at this juncture, on the last problem I did have stuff on the bottom and on the top, but none of them were of the same base, okay? Now you do have an a to the third and an a to the sixth, so you need to scribble out the a to the third and then subtract 3 from 6. That's going to be 3. Okay. Now that's a positive, so it comes over where it is. Keep that. Positive. And positive. That don't mean move it to the top. Positive exponents means you keep it where it's at. Okay. Negative exponents you move it. Positive exponents you keep it. 5 to the third. That's 5 times 5 times 5. That equals 125. 4 to the power of 3. That is 64. A to the third cannot be simplified. B to the third cannot be simplified. 8,000. Okay. So you got to multiply those two. Remember that. Okay, scientific notation. Simplify each expression. Write each expression in the proper form of scientific notation. So you're going to take 3.4 times 5.2, and you're going to take 10 to the 8th times 10 to the negative third. Okay. So 3.4 times 5.2 is 17.68 times 10. Now to find what the power of the 10 is, you add the powers. 8 plus negative 3 is 5. Okay, I add them. Now you got 2 digits in front of the decimal. Okay, you need to move it so there's 1. Now when you move it left, you add 1, because it's like you're making it smaller here, so then to balance it out, you add to your power. So it's 1.768 times 10 to the power of 6. Okay, now here's the same, kind of the same idea, it's just division. So we take 8.1 divided by 9, and then 10 to the power of 7 divided by 10 to the negative fifth. Okay, so I take 8.1 divided by 9, 0.9, times 10. Now when we divide, we subtract the exponents, but it's not 2. Here's why. We take 7 minus negative 5. 7 minus negative 5 is like 7 plus 5, and that would be 12. Now you don't have any, you need a number before the decimal, and it can't be just a single 0. So move it once, and you're at 9.0. But then you take 1 away, because you're making it bigger here, so you make the exponent smaller. Okay, graph the function. Just worry about the 5 to the second first. Okay. So if I take 5 to the second, that means 5 times 5, that's 25. So with if it's to the 5 to the negative second, it's just flipped, 1 over 25. 5 to the power of 1 would just be 5, and that'd be 1/5, and 5 to the power of 0 is 1. Now multiply all these by a half, okay? 12 and a half. I'm going to do these in my head to save time. 5 times a half is 2 and a half. 1 times a half is 1/2. 1/5 times a half is 1/10. 1/25 times a half is 1/50. Now, it's going to be a heck of a lot easier to start graphing here. Okay, we go by 2's, and then 2, 12 and a half. 2, 4, 6, 8, 10, 12, just go a little past 12. 1, 2 and a half, 2, so 1 and then 2 and then about right there. 0 1/2, and then all the rest of the points do is just get infinitely closer to the middle line. Okay, and then you never cross the line, you just go parallel to it. That's an exponent function. Okay, number 8. Okay, so now I'm taking 1/3 to the second power to lead off. So that is right here. So that means 1/3 times 1/3, and that's 1/9. Because 1 times 1 is 1, 3 times 3 is 9. So that's 9. Now with 1/3 to the first is 1/3, so that's 3. To the 0 is 1. Now take all of these times 3. So 1/9 times 3 is 1/3. Just use your calculator. 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. Now we graph down here first. Okay, that's where we have the big numbers at. We're gonna have to go by 5s. Okay, so I go left 2, 5, 10, 15, 20, 25. 5, 10. Okay, right there. And then all you do with the other points is get closer to the line. You don't have to really be precise with those. Okay, write the expression in radical form. This is a radical. It will be of a degree 5. It's a 5th root. Okay, and then you put 40x in parentheses. You can put a 1. If it's a 1, you really don't need to put it. You can if you want. Okay, write the 7th root of x to the 5th in rational exponents. Now you're doing the opposite. They give you this, you got to get here. But what I've given you is not as complex as this. You have a x to the 5th. You just underline it, put 7. X to the 5/7. Okay, story problem time. At a job, a person begins work with an annual salary of $35,000. The person's salary is to increase 3% per year. Find how much the person's annual salary after 8 years of working at this job. Okay, that's poorly worded on my part. So my units are dollars and years. So dollars per year. Dollars per year doesn't exist because it does not go by dollars per year. It goes by percent. So it is not going to be a linear equation. Okay, it's a percent per year. Increase 3%. So that's plus 3%, Holmes. Okay. All right, so with the percents, it will not be a linear function. It will be an exponent function, and the go-to is always y equals a times b to the x power. And we have to find our money amount, so that means we need to leave the y alone, okay? We are solving for the money down here. So we don't replace the y, okay? Now A is just a subset of y, okay? It's a money value, but it's where you started at. See, y is where the money ends at, okay? So A is going to be 35,000. And then B is either your growth factor or your decay factor. It's going to be growth because it's adding. So I take 100% plus 3%. That's 103%. So we move the decimal twice to the left, and I have 1.03. Now X is your years, and you've got 8 years. Punch it in. So you start off with 35,000 times 1 point. Here's why it's important to get the power. If you stop right there, that's after your first year. You have 8 years. Okay, so it's going to be $44,337. That's his salary after 8 years. Okay, number 12. And up here, the copy machine cut it off. That's NT. Okay. $8,000 is deposited into a bank account that earns 2% interest compounded quarterly. How much will it be in the account after 5 years? So you're solving for your A. Now P is your principal. Okay. And by the way, I'm going to actually go here and write what all these things represent. The A is what we're figuring out. P is the principal. That's $8,000. R is your percentage, but that has to be as a decimal, so you have to take 2%, move it twice to the left. So R is 0.02. We also have N. Now if it says compound quarterly, then N is 4. And then we have N, which I already know, and then T is the actual number of years you have, which is 5. So make the distinction right there. I don't think I did a good job explaining that first go around. P is a principal, that's your money. R is the percent, but you have to rewrite it as a decimal, 0.02. N is N is how many times within the year the interest is put onto your account. Quarterly means 4. There's 4 quarters in a year, so N is 4. If it said compounded monthly, N would be 12, because 12 times in a year. Quarterly means 4 times in a year, and then T is the years. Okay, so I just throw the numbers in. 8,000, 1, 0.02 is your R, divided by your N, which is 4. So the interest gets divided by 4, but then out here, then it's N times T, not N plus T. Okay, so N is 4. And T is 5. Because think of it, it's 4 times a year for 5 years, so that makes it 20 times the interest is added. So that's a lot of times, but to balance it out, the bank divides the rate by 2. You don't get as high of a rate on it. By 4, I should say. Okay, then I go from here, 8,000 times, let's get rid of that parentheses. First you divide, then you add 1. 1.005. Okay, then you just plug it in. 8,000 times 1.005. So that's a smaller growth factor than what you'd have if it was just 2%, but the power is much higher, so it's like it cancels it out. Okay, so $8,839. Okay, then our last problem. The Mississippi River discharges about 1.7 times 10 to the power of 7 liters of water every second. How many liters does the river discharge in 40 minutes? Okay. All right, so you got this you got this scientific notation quantity, and it's liters. You're going to figure out the liters, but it says per second. So to find how many liters it actually is, you're going to have to multiply it by how many seconds you have. It's not 40, okay? And don't take 40 divided by 60. Dude, every minute you have is 60 seconds. So if you have 2 minutes, that's 120. 3 minutes, 180. 4 minutes, I think I could just times it by 60, and that would be how many seconds are within 40 minutes. 2,400. Now you're going to leave the power at 10. That's the only base 10 you have, and then you're going to multiply the 1.7 by the 2,400. 4,080. Now that's good, well and good, but in proper scientific notation, you have to have only one digit in front of the decimal. Only that 4 should be there. So I moved it 3 times to the left, so I'm going to be adding 3. So it's 4.08. You can put the 0. I wouldn't. Okay, I just put if there's a 0 at the end, times 10 to the 10th.